Alright, in this video guys we're going to be looking at some more complex array functions. Create a new script, I'm going to create a new cell, and I'm going to introduce to you array multiplication. And just like I've suggested, I'm going to put a CLC at the front there. Alright, I've got an array. It's a row, it's got 3 elements, and its dimensions are 1 by 3. I want to multiply each element in that array by 3. Okay, so we're going to multiply by a scalar, x times 3. Alright, that seemed to work alright. MATLAB's smart enough to work out that if I multiply this by a scalar, then it's talking about multiplying each element in that array by that scalar. How about if I wanted to multiply 2 vectors together? Alright, so I'm going to create another one, y equals 4, 5, 6. And I'm going to go x times y. Now, is this going to work? Unfortunately, if I use the same multiply operator, MATLAB's going to treat it as though we're doing a matrix multiplication. It's not going to treat it that we're doing 1 times 4, 2 times 5, and 3 times 6. Right, it's going to treat them as though they're 2 matrices, and therefore they must follow the rules of matrices when multiplied together, which I'll show you shortly. To do what we want to do, we want to element-wise multiply 2 vectors together. And the way we do that is we add a little dot. So dot times is an operator in itself, and that tells MATLAB that we want to do the multiplication just like I showed you before. Alright, so in this case 1 times 4, 2 times 5, 3 times 6, and we get our resulting vector there. Alright, same applies for divide. If I try and do x over y, we'll get, unfortunately in this case, it does work, but it does a matrix division, which gives us a result that certainly we expected a vector back. We want x dot divided by y, so that we get 1 divided by 4, 2 divided by 5, and 3 divided by 6, which is this vector here. Alright, when it comes to powers, alright, we can also use the dot power operator. Okay. One thing to note also is that if I try to do it without, even with a scalar, it doesn't work with powers. Alright, it always treats it as a matrix, and it will not do that automatic transformation for us. So we must always add in the dot power, even if we're doing it with a scalar for the power operator. Alright, so those are the 3 new operators that I want you guys to see: dot times, dot power, sorry, dot divide, and dot power. So really we should call this array operators. Alright, and they work for whether you are actually doing something like x times 3, that'll also work too. So that's really what MATLAB's doing. It's working that one out for you. Okay, let's do some matrix operations. I use capital letters when I'm working with matrices. It just helps me distinguish it when I'm reading my code. So there's my matrix X. So if I wanted to, let's say, make this a little bit more complicated. There we go. So now it's no longer square, which is going to make things a bit interesting. Whenever we operate with matrices, when we're multiplying them, this is the rule that I always use. That ensures that I always get my matrices, or even vectors, are aligned the correct way in order to be able to multiply. So what this basically says is that the number of columns in the first matrix, or array or vector, that makes no difference, must equal the number of rows in the second matrix in order to be able to multiply them together. Then the result of the solution will be the number of rows in the first matrix and the number of columns in the second matrix. Let's give an example. So if I was to do x times x, we're going to get an error. Okay, the dimensions must agree. what I'm saying is n in the first matrix is 3, while n in the second matrix, because we've got x again, is only 2, so they don't work. If we transpose x, it turns it into a 3 by 2. So now we can do x times x transpose, and then like I said, we had 2 rows in the first column, 2 columns in the second, we get a 2 by 2 solution. So that's a matrix multiplication, which MATLAB does when you use just a single star and you're working with arrays. Okay, there are also operations you can do using divide, but that's a more advanced topic that we'll cover later in linear algebra. Alright, for now, just remember that if you are working with arrays, if you want element-wise, you're going to want to do dot times, dot divide, or dot power, while if you're actually working with matrices and you want to multiply matrices together, then make sure that you're using the single times. A couple of good examples to show you these rules. Let's create x again, and we'll just put semicolons so those don't get in the way here. So if I wanted to create a dot product, or also known as an inner product, okay, of x, so basically what I'm saying is I want to go x times x, but I want to make sure that the result is a scalar. So if I want the result to be a scalar, then m must be 1, so I put in a row vector, m times 3, which means I then must multiply it with a 3 times 1 to make sure that's a scalar. So I transpose the second one, and there's my dot product. Alright, so very easy. Row vector times a column vector will give you a dot product. In other words, 1 times 1, 2 plus 2 times 2 plus 3 times 3. That's effectively all we've done there. The corresponding outer product, if we wanted m to take on the form of a matrix, we would have x transpose times x, which gives us the outer product. And no, there are no other versions that you can use. All the other ones will give us errors, okay, given the examples that we've got here. Alright, so dot products is an example of a matrix multiplication, as is an outer product, and we can create and use matrices for both matrix multiplication of matrices, but also using them with just arrays.